Okay, so now we're actually going to do some examples, and we're going to go ahead and use Desmos to graph our system, and then we're going to determine whether these points here are a solution or not a solution. So I'm going to first type in y is less than or equal to 3. So I have y, and then to get that less than or equal to, again, I'm going to hit less than, and then I'm going to hit that equal sign on my keyboard. I'm going to click onto a new line, and then I'm going to have y is greater than x plus 2. And so this is what this system of linear inequalities looks like when I graph it. And all of my solutions are going to be in this overlapped area. So nothing in just the red, not just the black or the white, but only in this overlapped area. All the points in this are going to be a solution to this system. So I'm going to go ahead and type in these points actually into Desmos, and I want to see where they land and determine whether that means it's a solution or not. So I'm going to first type in -4, 1, comma 1. And I see that my blue point here, it does go in my overlapped region. So since it's in my overlapped region, this will be a solution. Okay, now let's try 0, 3. Okay, now this one's a little bit trickier. I see it is in my overlapped region, but it's on the boundary of it. So now I have to remember, okay, it's on a solid line. Does that mean it's a solution or is it not a solution? Well, if you recall from our last lesson, that means it is a solution. And that's because it's on the solid boundary. If it was on this dashed one, so like for instance, the point right here, 1, 0, that wouldn't be a solution because it's on the dashed line. Okay, let's try the next one, 3, 2. Okay, 3, 2, that does show up in a shaded area, but it's in just the black shaded area. So since it's not in the overlap, this is not a solution. And then looking at that very last point, -4, 6, I see, again, that one's in just the red shaded area, not the overlaps. This one's also not a solution. Okay, let's look at the next example. So another way that you guys can also type these in is using this keyboard down here. So if you say show keypad, it has your X and your Y and your symbols here. So I could do that instead. X plus, not times, plus Y is greater than or equal to 0. Okay, so you see something a little bit interesting happens with this one. I have parallel lines here, and they both are shaded in different directions here where I get this overlap. So all of my solutions for this system are going to be any points that are in between these two parallel lines, because that's where the shadings overlap. And since these are both solid boundary, that means that any point on these lines are also going to be a solution. So let's look at that first one. So my first one is 5, 2. I see that is not in my overlap, so that means this is not a solution. Okay, let's try that next one. So next one I have 1, comma 1. That one is in the overlap, so that means it is a solution. Okay, and my last one I have -2, comma 2. And I see that one ends up on my boundary line, but since again it's a solid boundary, that means it's a solution. If it was dashed, it wouldn't be a solution. Okay, go ahead and pause the video. I want you to try number 3. So go ahead and graph that using Desmos and tell me what happened and what you think the solutions are. When you think you got it, go ahead and press play. So what you should have seen here is I have two parallel lines kind of similar to our last problem. However, the shadings go in opposite directions, so there is no overlap. And so since my solutions, they're in where the shadings overlap. Since the shadings never overlap, whenever that happens, there's no solution. There is no ordered pair that if I plug it into these inequalities, that is true for both. Okay, let's do one last example. We'll see a couple of different things with this one. So here I have y is greater than 2x minus 3. Then y is greater than or equal to. To get that fraction, what you're going to do is you're going to do 1, and then you're going to hit that slash button. That's going to be the same button on your keyboard where your question mark is, and they'll automatically make a fraction for you. But then to get out of the fraction, so like right now if I type in x, it's going to be in there, I need to press on the right arrow key. And so I have that. So here I have green and purple shading, and all of my solutions are where those two different color shadings overlap. So let's try that first point. So my first point, I have 3, -1. I see that ends up in my white area where there's no shading at all, so that's not a solution. Okay, looking at my next point, I have 4, 5. I see that is in the boundary of my overlapped region. However, it is on a dashed line. So since it's on a dashed line, it's going to be not a solution. That's because it's a dashed boundary. Okay, let's try our next point. Our next point, I have 2, 2. So now for this one, I see it also ends up on a boundary line. However, this is a solid boundary line, and this is also in a boundary to the overlapped shaded region, so that means that this one is a solution. And my last one here, I have -1, 4. I see that is clearly in my overlapped shaded region, so that means that this one is a solution. There's one more example I want you guys to look at. Let's see if I had 5, no, let's do 8, 5. I see that ends up on my solid boundary line, so it's tempting to say that's a solution. But since this part of my line is not a boundary to my overlapped region, this would not be a solution. So it has to be only where my shadings overlap, has to be part of that boundary. Since this is just part of the purple shading, that won't be a solution. Okay, that is it for today. If you want to look at some extra examples, those are linked below. Otherwise, you can go ahead and move on to your exit ticket. Again, if you ever have any questions, you can always reach out to me. Hope you have a great rest of your day.